Welcome to Education Lifeline. This is Trishita Paul, and today we will be introducing the different ways to transform quadratic equations. Now, if you haven't watched our previous video on an introduction to transforming quadratics, the video will be linked in the description below, as well as in the top right-hand corner of your screen. Please check that video out before watching this one. So in this video, we're going to be using all the rules from our previous video in a multitude of practice problems. Our first one is y equals x plus 3 squared. Now, in order to graph this, we need to keep two equations in mind. The first one is the parent function, which is y equals x squared. And the second one is the equation for vertex form, which is y equals a times x minus h squared plus k. Now we see that there's no a value, or in this case a equals 1 and k equals 0, but we do see that this 3 corresponds to the h here, and because the 3 is positive, that means we move left 3 spaces from the origin to get our vertex. This means that we shift the parent function left 3 units, and we'll get a quadratic that looks something along the lines of this, where the parabola is shifted 3 units to the left because of this plus 3. Now our next problem is y equals negative x squared minus 5. Let's rewrite the equation for vertex form to help us look at this closer. So here we can notice two things. We have a negative in front of the x squared, which means that a is equal to negative 1. We also have this negative 5 after the x squared, which means k is equal to negative 5. And when we have a combination of transformations, we start with h and k and then move to the a value. So starting with k of negative 5 means we move down 5 units. So our graph is going to move down 5 units from the origin, and our new vertex will be at the point 0, negative 5. But we also have this negative 1, which means that we're going to reflect our parabola over the x-axis, or in this case over this line right here, to get our new parabola that looks something like this. So we can note two transformations in this parabola. One, it moves down 5 units, which is right here, and also it's reflected over the x-axis to get a downwards opening parabola, hence this negative 1 with the a. Now our next example is y is equal to 2x. Now if we think back to our vertex form equation, once again we have a times x minus h squared plus k. We can see that this 2 corresponds to the a right here, which means that we will be either shrinking or stretching the graph vertically, because a values have to change the vertical stretch, gives a vertical stretch or vertical shrink or a reflection. So in this case, the origin still stays the same because h is 0 and k is 0, which means the origin is still at 0, 0. However, it stretches the graph vertically because a is greater than 1. We have a vertical stretch where we're going to multiply 2 to every coordinate change. And our graph is going to look something like this, where there would be a difference of 1, now there's a difference of 2 units. The difference of 4 will be a difference of 8 units. And our parabola is going to look something along the lines of this. It's closer to each other. Now our last example is a combination of all transformations. We have y is equal to negative 2 times x plus 4 squared plus 3. I'm going to rewrite the equation for vertex form. It's important to keep in mind that we're going to start with the h, move to the k, and then move to the a at last. So this negative 4 means we're going to be moving left 4 units from the graph, and this k means we're moving up 3 units. So our vertex, another way to think about it is our vertex is at the point negative 4, 3, right here. Now that we've done our h and our k, we can look at our a value. And there's two things going on here with the negative 2. That means, one, we reflect the parabola, and 2, we also stretch by a factor of 2. So when we go to graph this, we're going down, and our original point would be here, but we're going to double that, double the difference, and our next point will be here. So we're moving downwards, and we're also stretching the graph. And our equation is going to look something like this when graphed. If this video was helpful, please drop a like and subscribe to Education Lifeline. Be sure to watch our next videos on quadratics and check the description below for more helpful resources. We include more tips as well as practice problems in the description of every video, and please make sure to leave any questions in the comments down below. Thanks for watching.